Right now, somewhere, a company is making a move in plain sight. The street reads the headline. Autonomy AI sees the signal. We deliver it before the market catches up. Autonomy AI. Your models, our intelligence. Request a private strategic briefing at AUTNMY.ai.
Tete, it's great to have you here on the road to autonomy. You're one of the co-authors of one of the most influential papers in computer vision, the segment anything. And it's not just that paper, sir. You published multiple papers. You've been cited over 30,000 times. That's impressive. You got like your own library there, sir. Talk about the impact that paper has had, please.
Yeah, thanks, Grayson. Appreciate you for having me here. I started my career in computer vision in 2015. And even at the outset of my research career, we always wanted to make the system work in all kinds of circumstances, to be able to detect objects reliably and also have these systems to be able to reason and generalize across different scenarios. The segment anything paper or the segment anything model was the first work that really achieved this. So before that, when we train these neural networks or a computer vision model, like it doesn't really work out of the data that was trained on. And the segment anything model fundamentally really changed that. So instead of having handcrafted classes, say like 100 different types of objects, like you can segment out any kind of object. So it was really the first work that transformed computer vision from the era of specific models into the era of foundation models and a generalizable system. So, the team was really proud of it, and I was really proud of the work.
What did you see technologically to come up with that concept of the team that you worked with to develop that paper, as you very kindly articulated, model?
The team I was with, they were some of the best experts in the field. They led the transformation in 2012, after 2012, uh, from the era of handcrafted features to really a learning-based system. So the team delivered again after that. So we had the inspiration and the insights of what a system, an ideal system, should look like. And in 20, while we were working on the paper, your ChatGPT was already out there, so we knew a new paradigm was possible, and some of the capacities from these AI models that we never dreamed of were possible. I really wanted to make it happen. So it was because of the insights, I suppose, and also the ambition of building a generalized system and a generalized model that really pushed us harder on thinking of how we can solve these some of the most challenging problems.
What initially drove you to developing models? Was it something in your childhood, your upbringing, or did you read a book or watch a movie as a child that really gave you that spark or that inspiration to go down this path?
I started programming when I was in primary school, and that was just serendipitous. Neither of my parents, were working in the industry, but I wanted to program a robot that could play soccer, tabletop soccer, and walked into the wrong room and started learning instead, how to program in Pascal and learning these algorithms. Some people might say that was child abuse, but I find it really, really fascinating. Fast forward, I got into college in the computer science department. At the time, I was doing software for a while, but I just was not very excited about it. And then I read about AI and neural networks. I was like, this was something I really wanted to work on. At least, got a sense of what it was like. So I started my career really in a research lab in computer vision. And it turned out that was the right thing to do. I have a sense for data. I loved, seeing these models do something on real images and videos. That was really exciting time.
The most important question: did your robot win tabletop? Did it win the tabletop game?
Well, I never got really to work on it. I mean, there was a lot of people trying to program that robot, and we didn't have many robots in my primary school. So, that's why I was just learning how to do binary search. It sounded boring, but it was actually a lot of fun.
It's not boring. My wife and I talk about this all the time. Different things throughout your life, different memories of things that you've done, and so you look at it. You go into a great research career. You have a stop at Facebook, now known as Meta. You do the research there, And now you're I want to say you're back to the tabletop days. You're playing with physical robots, and this time it's autonomous trucks.
Yeah, that's a fascinating problem. I mean, when Xiaodi invited me to visit the office, and I actually saw this truck running on the road, that was actually brought me back in the days. I worked on human robots during my doctoral program. At the time, it was not considered as something really exciting. Working on robotics is extremely hard, as you'll see actually in trucks as well, because these are physical AIs, and we have to deal with physical world problems. For the virtual AI model, when it makes a mistake, it carries on. But for a robot, for a truck, when it makes mistakes, it either falls or hits something, it's safety critical. We have to engineer the system and find these solutions really that are robust enough to be able to deploy in the real world. And I love the challenge. I really enjoyed actually solving these challenges.
It's a great challenge. I remember years ago before robotics came cool. I have a lot of friends at Carnegie Mellon. I went to the robotics lab there. I was like a kid in a candy store, or like a wannabe Willy Wonka, having fun looking at all these little cool robots that can do things. And now, obviously, you and I both know robots are all over the world. Physical AI is very hot. When you're developing a computer vision algorithm, or if you want to call it the term a stack, to drive a truck, how do you go about that? Because driving a car is different than driving a Class A truck versus driving a Class 6 truck. How do you go about developing a computer vision system?
So, the perception system or the computer vision system for these different types of vehicles are very different. For a small passenger vehicle, the braking distance is usually pretty short. It's about 100 yards, give or take. So the perception system, whether that's a modular perception system or end-to-end perception system, only has to see as far as 200, 250 yards, 250 yards. That's about it. But for a classic truck, the maneuverability is pretty poor, and we want to be predictable. And because the vehicle is pretty big, whenever we do something, it creates a mess really on the road. So we have to see far, far away. So the requirement for our perception system is that it has to reliably see, for example, moving vehicles as far as 500 yards. And we have to plan ahead what we like to do with this kind of system.
500 yards is 5 American football fields. That's quite a distance there. Are you looking 500 yards down the road from a safety perspective? So obviously, because the truck takes a longer time to stop than a pedestrian vehicle, is that why you're looking down 500 yards, or is it performance, or what is that?
So when we look at the autonomous driving system, we always approach that from two angles: efficiency and safety. Efficiency is all the challenges that are unrelated to safety. For example, we like the trucks to drive like a human being. And safety, of course, is safety. So the perception stack helps with both efficiency and safety problems. When we can look afar, we can plan ahead so that we can drive just like a human being. And when we plan ahead, we can see the dangers coming. For example, if it's a debris on the road, or is a stopped emergency lane vehicle, or it might be a cyclist, right, just 400, 500 yards away. And we want to maneuver around that. So from both angles, we need a long perception distance, and that's quite different from passenger vehicles. And also because our ODD is mostly on highway, so when we are driving at a fast speed, will have to give us, more time to react to it. And more time and higher speed means, higher distance.
What type of redundancy do you have to build into the system when you're operating at those higher speeds?
We have redundancies on both software and hardware level. So in the system, we always enumerate safe outcomes. For example, stopping the vehicle and keeping the lane has to be an option at any given time. I mean, that's the same with human drivers, right? We can avoid a collision obstacle, but also, we can just slow down and remain in the lane. That's always an option. That's one of many redundancy designs for the software system. For example, when the sensor goes out, the software should be able to handle that either by pulling over or slowing down. It has to be safe all the time. On the hardware side, we have hardware redundancy, such as on the braking system we have two, onboard computer, we currently have 2, and also we're going to have 3 of that in the future. So any of the system fails, we will be able to at least, maneuver to an emergency lane, keep driving for a couple minutes, or just stop in a lane. One analogy I always make is with the aviation industry. For example, on the plane, there are usually 3 autopilot systems, and for us, it's the same. We actually design our systems with a lot of inspiration from the aviation industry.
Software redundancy is fascinating. And I'm just asking this in very simple terms, if you'd be so kind to break it down. Is that where you have, let's call it 2 versions, identical versions, twins, if you want to use the term, like a digital twin in aviation is used quite a bit, where you're running digital twins on 2 separate pieces of hardware? Is that what it is, or is it something different?
So you're talking about a mirror redundancy system, meaning like, we have system A and B, and both the system, although they are running on different hardware, they're running on essentially the single piece of code. Some part of redundancy is like that, and on system level, it's not, because we like to make sure that if one version of Sims fails for whatever reason that is, and sometimes we don't know what we don't know, right? We don't want the identical system that might have exactly the same problem to be running on a different machine, although we intend that to be a redundancy system. So we change our algorithms, and we change some of the logics, just so that they are as independent as possible. Because when 2 systems are independent, their failure rate will be independent as well, and that significantly reduces the risk of the overall system.
I'm impressed. I'll just say point blank, super, super impressed. Now I'm going to have to put on my pretend engineering hat and ask you the layman question. How do you engineer that? How do you build that?
Well, we build it from top down. Like, we think of, what a good system looks like. We break into a part. We never go bottom up on this thing and be like, we have a couple models, let's stitch them together and see, like, how they work. Because this is such a safety critical industry, we actually from the day one design all these different components, and then try to engineer these different components in the way possible. But of course, engineering is never perfect, AI is never perfect, and then we implement these fallback measures, and we calculate the failure rate of each individual module, so that mathematically we can calculate the failure rate of the entire system. And as long as the rate is acceptable, for example, it happens once every 100 years or something like that, with 1,000, 10,000 trucks running on the road, we'll be like, well, that hardware design is pretty safe. So this is how we think about risk. We also run lots of simulation. A couple hours of simulation, our entire cluster is equal to driving for hundreds of years in human life. So we also eliminate as much of the risk possible in the simulation as well. So the system is engineered around safety. It's a lot of challenges, but it's quite doable.
When you're building the system, and let's just say there's a whiteboard in front of you, and you say, okay, I'm going to build an autonomous truck. Do you start with the software development first and then do the hardware architecture, or do you kind of run them in parallel to get to what you described to achieve and then unlock all those safety?
So we do that always iteratively. Um, Hardware and software design usually start at the same time, with the end goal, of course, the truck being able to drive on its own efficiently and safely. So we assign the task to hardware and software teams, and they talk all the time. Even from the evolutionary perspective, I mean, human intelligence or any lives on planet Earth, evolve on both software, which is our brain, if you think about it, and hardware, which is our body, and they co-evolve. And for the physical AI company, since we do have these 2 components, internally we have the 2 teams, working side by side, always side by side. And sometimes, the software can solve a problem that's very hard for the hardware team, and we solve it in the hardware. We solve that on software side, and vice versa. But of course, iterating on software is always faster than a hardware platform. So we try to make the hardware team life a little bit easier by not, having a lot of requests every week. But we do iterate on the platform, every couple months. Our truck currently is at generation version 1.5. It's a huge upgrade already from the very first generation uh, that we tried, a year and a half ago, and now we're working at full speed towards the second generation of our sensor layout and our, software stack.
So, for context, I was in that original truck, and the Shadi was very kind, along with Robert, and hosted me, and I went and experienced that truck from somebody myself who's been in the earlier version of the truck to the 1.5 version. How would you describe the difference in terms of performance?
The first generation is the proof of concept. So it shows that we're capable of uh, running a driverless truck on its own safely and efficiently. That was a proof of concept. But of course, if you look at the sensor layout, they're very expensive. They're all premium sensors. And also, on the software side, it was not designed to be operating on daily basis. But to make it work, the truck has to be able to drive on daily basis. We've significantly expanded the ODD. Not only we can drive during the day, but also in the night. Not only during a sunny day, but also during a rainy day and fog, and dense traffic, local road, and all of that. So our second generation is capable of continuously operating as a driverless truck in the major ODD in the state of Texas and in actually most of the states in the United States.
Is we're going to call it version 2.0 of the truck, is that the truck that when you launch commercial service this spring with Ryan Transportation for the audience, which will be fully autonomous, no safety driver, no observer in the cab, will that be version 2.0 of your truck?
That is correct. On software, that is 1 to 2.0. The hardware platform is still 1.5, and it will be upgraded later this year.
And how are you preparing for that launch? Because it's a milestone, because it's not based on the announcement that came out that FreightWaves covered. It's not a pilot. It's not a one-off. According to the release, it's going to be commercial.
That's right. That's right. It's not going to be one off. It's not a proof of concept. It's to show the world that we're here. And when you're at I-10 or I-45, you'll be able to see our trucks actually running on the road. Actually outside of this office, people are working, tirelessly to make that happen. There's a lot of work to do, right? Like there are new features that were developed a couple months ago, and they've been tested like extensively during the past couple of weeks and months. The full system has been integrated, and people are just running some of the final checks. People are very confident, they are excited, but we're doing our work to make sure that it's safe, and also like it can do the mission that it's designed to do. So we're really really excited about it.
Is the mission be similar to what I experienced roughly a year and a half ago in Houston, where it'll do the freeway driving and then it'll go off for a certain period of time to the loading dock? Will it go that whole distance?
It will, and it will go. In terms of distance, it will go much farther than you probably the route that you experienced. So from, for example, Houston to Dallas, that's 4.5 hour drive. More than 200 miles. And not only we're doing one direction, we're doing both directions because again, this is not a proof of concept, right? When the truck goes there, it has to come back. If we only do it one direction, that's still a proof of concept. We still have to have a human driver over there and wait and drive the truck back. So that's very different from what you've experienced a year and a half ago. Bot Auto is a company that moves very fast, and it's because all the amazing team members that we have, and also the experience that we had in AI and autonomous driving. Safety is always the highest priority. The team has demonstrated that, and also demonstrated that we can innovate at a rapid speed while being very safe.
To put that into context, the company is less than 3 years old. Staying on the AI theme here with your background in AI, would the bot auto team have been able to achieve what they have today without all the technical breakthroughs we've had in AI?
Bot Auto wouldn't have been possible without all the breakthroughs in AI that were around the time of 2022. So at the time, the industry transformed from using, these handcrafted stitching together models to a unified foundation model and world model-based framework. And that really separates apart. Um, in terms of technology and company operation, it makes us more efficient. Some of the teams that we have here are doing the work with only 2 people that some other companies spend 20, 30, 40 people working on. And our system is actually better. Well, that's because we don't have this debt, and we're able to leverage the latest and greatest systems. And that's from not only open source projects and also industrial research, but also our own research and development. Because now fundamentally we can use a different type of mindset to tackle these challenges. We talk about foundation model as the example by the segment anything model, but also large scale reinforcement learning. Large scale reinforcement learning was there with AlphaGo and AlphaZero when they beat some of the best Go players in the world. But the first generation of the system still uses human knowledge, right? It learns how the humans would like to move, and of course, on top of it, explore on its own. But if you look at Alpha Zero, which is the system that can play Go, explore and figure out how to play that game on its own without any prior human knowledge. And it actually converges faster, it trains faster, it performs better. Well, that's because, if you unleash the power of compute, the computer is able to figure out better moves, better strategies, safer strategies. And that's the same for driving as well. I always say like driving is kind of like playing games, except like your reward, of course, are twofold. One, you don't want to run into anything. There's no collision, right? But also you don't want to be liable because there are traffic rules and the rules are pretty clear. And you don't want to get into any liable accidents. And of course, you also want to, get to wherever you want to go, within some period of time. So these are essentially like playing a game. You get rewards for achieving these type of goals. So with large-scale reinforcement learning and the explosion really in GPU power and compute, we're able to do so many things that wouldn't be possible before. And in terms of validation, I mean, we talk about validation all the time in the autonomous driving industry, because for any system, even when we change a single line of code, we have to validate that the change is safe on the whole system level. So we need to run simulation. But in these simulations, the road users can do all sorts of things, or should be able to do all sorts of things, right? That we can't just run simulation in a world that's perfectly safe, where everybody is a law-abiding citizen. That's not the case, right? There are drunk drivers who, from the computational perspective, might just have a shorter perception range and the lower maneuverability, right? It might just be, bouncing around between 2 lanes. Then we should be able to simulate that all with AIs. So the industry is very different today than it was 3 years ago.
The industry's changing, and for the audience, I'd highly recommend watching the Thinking Game on YouTube with Demis and the team at DeepMind created is fascinating. And I showed it to a few teachers that I know, and it scared the living pants out of them. Said, "Oh wow, this is coming fast." I said, "Yes, it's these massive technical breakthroughs when you put your head down and you build great things happen." I'm curious. So you mentioned GPUs. Could this is a hypothetical? Over time, as technology evolves, could you see a point where the bot auto is trained on TPUs versus GPUs, or do you always have to stay on GPUs?
We're open to both computational platforms and accelerators. Actually, we are not inherently limited by one type of accelerator or another. Um, so far, so our deployment framework, so the onboarding computer is actually the GPU platform. So it's easier for us to develop these models on a GPU platform and also, deploy on a GPU platform. But inherently, there's no limit between the two. We're open to all kinds of accelerators, um, and there's no any limitation on code level.
Where does RAM come into the picture? Because there's all this talk now, especially with OpenClaw taking off, and you've seen all the public reports out of Micron, which is publicly traded, of RAM shortage. What role does RAM play in the bot auto model?
It plays a role that just like any computer that needs RAM. So this where like some of these intermediate data stored and they're transferred between CPUs and GPUs. But the RAM shortage is really caused by these supercomputers. As back in the days, I remember 10 years ago, a GPU cluster doesn't have that much RAM, on it, but because of LLMs and these are huge models, so we need more and more RAMs to be able to perform this computation. For us, it doesn't really impact us that much. We're not deploying, for example, trillion parameter models on the vehicle. I mean, we don't have that much compute anyway. And also, driving is supposed to be simple, right? Some people can drive while thinking of something else. It's not supposed to be something where you dump like 1,000 brains into and so that you could solve it. So far, the RAM shortage is not impacting us.
Okay, you stepped into it. I'm following your lead. This is hypothetical. Doesn't happen. Nobody has it today outside of Alphabet. What happened if you had the bot auto data center and I said, okay, Tete, here's unlimited compute, unlimited RAM. Oh, and by the way, I'm going to give you the most important part you need. Here's the power you need to do it. Would that change anything from a development cycle of where bots going?
So it definitely can accelerate a lot of things. We have a lot of new ideas. And the company has been essentially transformed from a data-driven paradigm to a compute-driven paradigm. So back in the days, companies are really limited by data and mileage. You have to have, dozens of trucks or hundreds of trucks going out there to collect all the data. But now, compute is the bottleneck. You give me the compute, I can always use it one way or another, either by, making the reinforcement learning algorithms better or the policy better, or to be able to, mine, better data and cases out of the models that we already have. So that's great. On the other hand, we don't really need to boil the ocean. We like to be 1,000 GPU or GPUs in thousands company as of today. And also, to expand a little bit, since we're a physical AI company, one day we'll have to work on robotics as well, right? If the truck stops in an emergency lane, well, you need a robot really to, to come out of the truck and put these cones, right? 100, 150 yards behind the trucks. So we'll have to work on that as well. And that's going to be pretty compute intensive. But so far, we're happy with the amount of compute we're having today. It's not limiting the technology, but it's always better to have significantly more. It's going to accelerate the timeline.
There's a debate. If you talk to the economist friends of mine, where on-prem versus off-prem, it's like, okay, so once you get to a certain scale, the cloud doesn't make economic sense. How is bot thinking about that? Are you running on-prem NVIDIA GPUs? Are you running in cloud? You're running a hybrid? What type of compute strategy are you running?
Absolutely, we do both. We have our own clusters and data centers. So we have self-hosted storage, accelerators, supercomputers, and all that. But also we leverage cloud compute as well. So they really serve as different purposes. When we have our own data center, it's somewhere, and we have to deal with, for example, networks, cooling, and all that. So when we move data is not as easy, right? When we have office, for example, in Boston, it's not as easy to be able to access this data from our own data centers. And also, we want to have redundancy in data center as well. What if there's a hurricane and then the data center is flooded? Then we like to keep a copy of the data somewhere else. So there's always a copy of our core data on cloud storage. So as a redundancy and a backup. And also, cloud compute offers something that our data center cannot, which is scalability and to be able to handle this elastic requests. When it's like a coffee shop, sometimes the coffee shop doesn't have as many customers as when it's like 8 a.m. in the morning when everybody goes out and tries to get coffee, right? But if I staff my coffee shop as if we're always handling the peak traffic, well, what are they going to do when it's 3 p.m. in the afternoon, right? But if we don't have enough staff for the coffee shop, well, there's going to be a huge line every day at 8 a.m. So, cloud compute can be a buffer for that. When we have a lot of requests we need to process, we actually send it to a overflow zone on the cloud and to process that and get results back. But when it's not at its peak, when our own cluster can handle it, we always send the request first to our own clusters. And actually, we design our system and software platform to be agnostic to whether the request is sent to our own cluster or the cloud compute. Is designed in such way.
So to me, it's a risk mitigation strategy at the end of the day. You talked about risk mitigation from deploying on public roads. You're talking about risk mitigation from a data perspective. As AI gets better, GPUs get stronger and stronger. Do you just keep adapting and putting these new technologies and new compute into your stack? Because you've seen some legacy companies. I'm not going to name names, but we've seen legacy companies. They get very happy in the little moat, and this new technology comes along. And they don't embrace it. How do you avoid those mistakes that so many companies in the past have made? I will give a name. IBM. Look at the classic mistakes that they made. How do you avoid those mistakes, especially as this technology is changing so quickly?
In the technological history perspective, disruptive technology changes the play field, right? Um, Automobile companies started to manufacture internal combustion engines and transmission in the year of, I think, 1880s, right? They had a positive business cycles. They were the earliest. They made the products that everybody wanted. So they generated a lot of cash flow. They were perceived as leading, so they attracted talents. They made better products. They sold better, and on and on and on. So these cycles reinforces itself until when there's a disruptive new technology that changes fundamentally how they do things, how we do things, how consumer behaves. That's electric vehicles. Now the new technology is not focused on internal combustion engines or transmission anymore. It's battery technology, it's electric motors, and it's electronic control. And so that opens the door to a new generation of company to innovate around this old mode and really take a leap forward and become the new market leaders. So that's something that's really important. The question isn't even about like how much money you've raised or how much money you have. It's about how many good decisions you make, on every dollar that you have. You have a lot of money, you don't make good decisions, that doesn't make sense, right? And we actually have this old saying in Chinese that goes being vigilant and prepared, even being peaceful and prosperous times. So actually, from I think it was from 5th or 6th century BCE, it's a great philosophy. But in Bao Dao, of course, we're small. When we get big, we will never view ourselves as incumbent company. Because when we start to do that, we have a risk of falling behind. And my job to the team is actually to balance, the system we currently have and also the innovation that's possible to bring us forward. When we take a huge leap forward, we always have to calculate the risk. Is this system actually feasible? Is this grand new idea actually feasible? As safe, efficient, and doesn't, blow everything up? And that's my job in Tete Xiao, to always evaluate these questions. But we also need to be bold because the world is fast and it's brutal. It never stops and waits for any single individual or a team or a company. We have to innovate. And the model that I always say to other folks is like, we are the best company, one of the best companies in the industry in the year of 2026. But can we be that in the year of 2028? Can you possibly imagine what the technology will look like in the year of 2028 or 2030? Now let's get prepared. Let's work on it. The team is always working on something futuristic. We never just look back and be like what the best technology was in the past 2 years. It's always what will be the new technology in the next 2 years.
That's what you have to be. And if you look at OpenAI with ChatGPT, if they had a different mentality, we used to be on ChatGPT 3, and the same thing with Anthropic, because if you look at Opus 4.6 from Anthropic has been this major technical breakthrough, especially from a coding perspective. I use it all the time. But yet that took years to get there. Same thing, ChatGPT 5.2. I'm not a Codex guy. I like Opus 4.6, but ChatGPT 5.2 does have some strengths along with Gemini 3.1 Pro. They all have their own unique strengths, but these take years to get there. Culturally, how do you keep the engineering and software teams focused on continuing to build and continuing to evolve? And then also, as you do that, how do you ensure that they're putting these new advanced tools into their workflows?
My own philosophy has always been to get the best ideas of everyone. I don't go in and tell people this is exactly the system you have to implement, or this is exactly the thing you're supposed to do. Because I fundamentally believe, well, for this, especially this small elite team, everybody has a lot of knowledge in the problem space. Everybody's extremely smart. And if we really sit down and work out the best idea and make the best idea win, that's the culture here. Um, you know, when the software team, the engineering team, and hardware team sit down together, there's no hierarchies, no ranks. We talk about things, then we debate, and we find the best solution possible. So I view my work and Xiaodi's work as more of an inspirational work. We talk about the trends of technology and we make predictions based on this trend. What is the most likely scenario of a certain type of technology to work, and also to connect that with our own experiences. Because when you make a bet, the software team will not make any progress or waste months or even years of time. So that's where the training in academics and research come in handy, because we're familiar with the technology, so that hopefully our prediction is a little bit better than the industrial average, and that can really give us a lot of lead over time, because we save 3 months here, we save 3 months there, and you combine all of that, we saved already a year or two. And we want to move fast all the time. And in terms of culture, I think when you lose the culture, you will never be able to get it back. When the company stops innovating and view itself as incumbent, and life is so good that I don't even need to come into the office and think about these hard problems today or tomorrow or this week or next month, when you don't have the urgency of doing something, you will fall behind. And when you fall behind, there's no way to get it back, because leadership views it differently. The managers view it differently, and it propagates all the way back to every individual engineer. So at Bob, we always want to be a company that has a sense of urgency, and we always want to move fast. Whether that's the problem that we're working on today, or probably will work on in the coming months and years.
When you're looking to make predictions, you're looking to see kind of use the Gretzky term, you're going to skate to where the puck's going. Are you looking at RVEX papers? Are you looking at research papers of stuff that's coming out of labs or coming out of academia to give you I don't know, call it a hint or a clue perhaps of where the breakthroughs might be coming from?
That's certainly a source of inspiration. I still read papers every day. I try to learn the best and latest, coming out of research labs, and also that gives me new ideas. It's to be honest, that's fun. Like reading papers is fun. Getting new ideas is always fun. But we have to combine that with the actual problems that we're solving, because this team is the experts. They has the domain knowledge. I'll give you one example, right? If you look at autonomous driving papers that comes out of academia labs, these are mostly on passenger vehicles, because, well, there are so many research on trucks. And as we just talked about a couple minutes ago, the AI on trucks is quite different actually from passenger vehicles. So we need to do a lot of innovations on our own. So, we have these internal discussions all the time. We sit down around the table or around lunchtime, and we throw out new ideas and really talk about it. And it's a lot of fun. I think this is only actually possible in a startup. So we like to be that way.
Startups are fun because you can collaborate. When you look at collaboration tools, Are you guys having AI write any of the code that you're putting into the system?
I'm sure, every engineer is using some kind of AI all the time, and that's encouraged, of course, because this is such a new technology. And I think, everybody should try and make their own decisions. On a company level, of course, these are encouraged because I do think it made a lot of things possible that was not possible before. So I look at AI generally from the two perspectives. So does it create productivity that can be measurable? But that's quite straightforward. Like how many hours it can save you by accomplishing a task. It's tangible, but also sometimes it's limited, right? Because the best that I can get out of it is to save a couple hours here and there. And then the second category I look at things is whether it can create new goods and services inside the company, right? If a product manager who doesn't know how to code before now can leverage Claude AI models to program um, some of these business intelligence features, um, can we build better products? Can we make our fleet more efficient? So by doing that, we're actually looking at new goods and services and new ideas, new inspiration. I think both of these categories are quite important in AI, but to me personally, I do believe that a new innovation should be able to create a new kinds of goods and services. Now that being said, all our onboard compute and onboard related code is 100% written by a human being. Because it's a new technology, we want to be extra careful. We're not going to cut corners on anything that's related to onboard safety and the actual piece of software that's running in the truck, and also the piece of software that can impact or influence these trucks' behaviors. These are 100% human written code.
Which is smart because we've seen in traditional LLMs hallucinations, but now we're starting to see models have personalities. And I'm not saying this is right. I'm not saying this is wrong. And I haven't independently verified this because I don't think we can yet. You see some of the stuff on X around OpenClaw and the personality of the lobster army has had. How, when you're building the bot driver, you're building this AI system, you're building a brain, you're enabling it to learn. How do you ensure that the brain doesn't get a personality?
We absolutely do not want any personality in the bot drive. We want it to be as boring as possible. There's no emotion. It's not like, I got cut in, that's why I'm gonna come back. No, just don't, right? Just behave and be predictable. So we do this by tuning these reward functions. When we develop these policies, we penalize the certain types of behaviors that are aggressive, that do not follow traffic rules, that might cause safety problems. And actually, if I have to say, like, I'm engineering the whole society, if everybody is following rules, you actually make a more efficient transportation system. There are actually academic papers that prove this. If the drivers on each individual vehicle can talk to each other and plan with each other, you make the entire traffic system a lot more efficient, actually. Of course, I don't get to control our other vehicles. What I can do is to make it predictable. And what does it mean by being predictable? Well, that just means they follow traffic rules, and that's it. There are philosophical questions, right? Like, if I go ahead, I hit one person, and if I change the lane, I hit a couple others. What am I supposed to do? Well, in the context of driving, the answer is clear: is to follow the rules so that other road users know what you're going to do. You're not going to do anything that is a surprise to anyone around you. And that's how we engineer the system.
How do you avoid the surprises? I say that because if you look at the bot driver, model citizen, not speeding, not going wackadoodle, no Mad Max, just plain vanilla driver. And then you mentioned earlier, if a drunk driver goes, how do you get the bot driver to blend in when there's so many unpredictable elements that happen every single day on the road? Not to mention you're based in Houston And boy, oh boy, that traffic, I gotta tell you, that's something else down there.
Yeah, when I went from California to Houston, I thought Californian drivers were aggressive enough, and until I got to Houston, well, it's a whole new world. Absolutely. We can drive defensively from the policy perspective. We do our thing as just like a human driver. I've seen drunk drivers on the road. Sometimes what I can do, right, is to be far away from these people and then just do my business. And from the engineering perspective, we simulate these situations extensively, in our simulation with the help of large-scale reinforcement learning. So, of course, we can't enumerate every single scenario if we do it by hand. There's always something new coming out of it. So to solve this, really, compute is the answer. We leverage a lot of compute. We're able to run the clock, run the time at a significant speed than the real world. So when we do that in a smart way, we're able to cover, most, if not all, the cases that are possible on the road. If we're ever in a situation, where collision is not possible, but is impossible to avoid, and that's going to happen, right? If we're just, minding our way and someone, hits the car from behind, I can't do really anything about it. So in those situations, we look at liability. So we're talking about the end-to-end system with verifiable safety rule and liability checks. So what that means is that, well, if the collision is not possible to avoid, we look at the traffic rules, we look at the liability checks, we maneuver in a way that minimizes the contact, and also to make sure that we follow the rule all the time.
So what you just described is you're building an AI driver that's going to inherently make the road safer because it has no emotion.
Absolutely.
Then the next evolution in AI that's talked about a lot is AGI. What happens when AGI is achieved to autonomous driving?
Well, I think Bot Auto is going to build the AGI in autonomous driving, because the question is in a driving, right? So there are different definitions of the AGI, but academically, I think there's a clear definition. So it's the AI that exhibits all kinds of mental and physical capabilities as any human being. That doesn't mean the AI has to be smarter than human beings on everything. It just means, well, if you treat it as human beings and it learns on its own, it's going to behave like human beings. It can do all the work that we can do. So I think there's a clear definition of AGI in a broader sense. If we talk about AGI in autonomous driving, essentially my definition is level 5. It just means there's no ODD. It's just like a human driver, and it drives much safer than a human driver. It can drive in all sorts of conditions the human driver would, and it's going to drive as efficient as a human driver. And that's our definition of AGI in autonomous driving or autonomous trucks. And Bot Auto will be able to achieve that with our innovation and technology that we're already building.
So then is Bot Auto operating as a frontier lab? Is it operating as a trucking company? Because the technological breakthroughs that you're describing clearly sound like a frontier lab.
I'll have to say my personal opinion on that. So when I look at Bot Auto as a company, I see a lot of similarity with SpaceX. It's a technology-driven company. Well, if you can't engineer the rocket, if you can't build it, you don't make cheap enough, well, all bets are off the table. Like, we're not even having a conversation, right? Here is the same. Well, we have to build the technology first, and technology is very important for the company. And furthermore, it's business-driven. We can't just build rockets. We can't just build autonomous trucks. We can't just license the software. We'll have to actually solve the problem. Speaking of SaaS versus transportation service, as we're doing right now, doing SaaS in this industry is like licensing out a technology for a rocket engine. So I'm going to license you the secret sauce of making the rocket engine, and you go build it your own. Oh, by the way, you also have to build a rocket. And you need to work with a launch facility, and you need to figure out, how to get the customers. That's not how it works. The business is simple. For the rocket launch is to shoot something in outer space, to push into the orbit. That's the business model. You charge based on that. How much the payload, how many times. As simple as that. There's no tricks in that business model. Is to shoot stuff into outer space. That's it. For us, it's as simple as that. We're going to move a trailer from place X to place Y. And you calculate how far it is between the two. Give us a quote. We'll do that. There's no cleverness around, licensing fees, storage, and whatnot. It's about transportation. So I wouldn't call ourselves a frontier lab. We are a transportation company that's in the physical AI space, that's developing the cutting edge physical AI technology. That's who we are. But fundamentally, we need to make the business work. That's why we're doing all the operations.
I like the SpaceX analogy. You're right, because they're vertically integrated. You have that basically, I use the term the frontier lab, the engineering, the technological breakthroughs. Then you have the mechanism, the rocket, and then you have the Dragon capsule to move individuals and to move payloads into space. And with Bot, you have your frontier lab, your engineering AI teams, and then you have your trucks to move the payloads. They have your public one from Houston to Dallas and vice versa, back and forth. So on the SpaceX analogy, what's your Starlink?
I'll give you an honest answer. I don't know. I'm pretty sure Elon, when he started SpaceX, he did not have a clue about Starlinks, right? It was about use Uber rockets and all that. But along the way, as genius as he is, he figured out, well, providing internet service to every corner on planet Earth is a pretty good business. We're using Starlinks in some of these, hubs that we're operating, because these hubs are generally out of a major city. It doesn't always have good cellular signal. So we do have actually a couple of starting stations here and there, to so that the driver and autonomous trucks can talk to us in these hubs to be able to get dispatched, actually, to get dispatched out. It's an amazing idea. For this company, our fundamental is transportation. We're moving goods here and there. We're already achieving, for our driverless trucks, the cost per mile is much lower than the human operated truck. And when we keep operating that, it's already a big enough market, right? I'm sure you're familiar with this. 75% of cargoes are being moved by trucks in the United States, $1 trillion market. Half of that, so $500 billion, is Class 8 semi trucks. Just on its own, we're talking about a huge market. And among this $500 billion market, 8% is in the state of Texas, right? Just 3 cities and going to the border. So that's a $40 billion market. So we're in a huge market where our core business is strong and it's huge. And we are staying, I would say, we always keep an eye on, is there another way, whether there's another way of monetizing the business.
See, that's what you are building, and Shouty and Robert and the whole team. You're building a business. You're not building a science project. You're not doing pilots. You're doing commercial operations, and we can't wait to see your launch this spring of drive route, no safety observer, no safety driver, fully autonomous, no human in the cab. When you launch that with Ryan Transportation this spring. Tete, this has been a fun conversation all over the map, from AI to trucking. And as we look to wrap up, sir, I'm going to ask you this: what is the future of Bot Auto?
Well, the future is bright. We need to scale in the near future. After we started operating continuously and commercially. I believe Bot Auto scale in autonomous driving will be at Waymo scale today in robotaxi in the next couple of years. And there are no incumbents really in autonomous trucking companies. We need the capital in the future to scale up, and all the companies in the space should work together. There's no competition. The real competition is with status quo, is with driver shortage, is with inflation, is with the fact that every American family is paying more than $3,000 a year on transportation. Actually, is invisible, but everything that we have from the small cell phone to a couch is moved by a truck. So these costs is everywhere, and that's really the competition that we're fighting together, I think, as the industry. And we'll expand into other sectors in the physical world as well. Of course, the cost can be lower, but at some point, we're not going to hit the energy issue, right? The price of sending something, just the energy cost, will become a major bottleneck in the industry if we want to continuously operate down the cost. And we're looking into that as well. And we are looking to other sectors in the physical world, because fundamentally we're a physical AI company. There's no limit to what we can do as a company in the future. So I'm really excited about Bot future, and I think what a time to be alive.
It's a great time to be alive, and you clearly articulated it in this conversation. AI is powering the future. There's no doubt about that, and you're 100% correct. The autonomous trucking industry, as well as the robotaxi industry, we all need to work together collectively to usher in this era, which I call the autonomy economy, because there is plenty of the pie to go around, and we all have to work together because a good industry lifts all boats, and in this case, all trucks. The future is bright. The future is autonomous. The future is bot auto. Tete, thank you so much for coming on the road to autonomy today.
Thank you.